Okay, today is February the 1st, 2016. We're watching the water vapor loop for the Northeast Pacific, and we're watching a very powerful storm. This is a 957 millibar hurricane force storm. And we can see that the core is being worked on. There is a asymmetrical feature right here. Transmitter is hitting the core of this to weaken the core pressure. And this system is moving towards Canada right now. That is a hurricane force storm, very large system. In the meantime, we've got high pressure installed off of California and Oregon and Washington. We'll take a look at that. We've got clockwise rotation right here. And we have a lot of outflow shown here on the satellite. You can see that right here from all that high pressure being installed into place. Today we had heavy chemtrailing going on in the Los Angeles region. Right now at 10:30 we have a temperature of 37 degrees. We've got a relative humidity of 43%. The dew point is 18 degrees. And the barometric pressure is 30.04. All right. And once again, we had a lot of chemtrail activity today. Aerosols being sprayed. And that was because of this moisture field moving through the region. And I will forecast more chemtrails for tomorrow based on everything that's moving right towards the west coast. We have a jet stream flow that's moving just to the south of California, mainly through Mexico and Baja, and out towards the northeast. Now, the storm that was here yesterday in Southern California has moved out over New Mexico and Colorado, and this is spinning rather vigorously. But we have some interesting anomalies here. We have an area of high pressure that just opens up out of nowhere right here. And we have a lot of very turbulent features right in the core of this system, which is causing some clockwise rotation right here. So what's happening is we've got descending air right on the core of this low pressure system. And if we look at some of these maps, if we take a look at the 500 millibar vertical velocity map, we can see that there is indications down here on the scale that of strong descending air occurring all through this low pressure system. All right, let's go back and take a look again at this situation. This is the storm that went right through California. We have an interesting feature right here. This ring moves out to the southeast, right there, that ring. And that is an interesting feature. That indicates outflow from high pressure descending air right there. If you look at the water vapor map again, this area here is just cleared out. And it's quite interesting to see. And this feature right there, that doesn't look symmetrical at all. There's just a lot of chaotic behavior in the core of this system. And we have some clockwise rotation right up here. And that is from this descending air disrupting the core of this system. So we watched a rather weak system that dropped barely an inch and a third of rain over Los Angeles. The core moved right over Los Angeles, basically Point Conception. And as soon as it leaves California, it's quickly rebuilt, even though they've got a transmitter on this thing. We can see that there. All right. And we have high pressure all through here. All right, let's take a look at the surface analysis map. And we can see that large storm, that giant storm, is 957 millibar. It's moving sort of in a east-northeast direction. And we've got high pressure prepared right all through here, and that will block this system from delivering rain into California and the West Coast mostly. Certainly we won't get any rain in Southern California. That's 1,031 millibar right there. We'll just keep an eye on all this and see what happens. But there's a no rain forecast for Southern California for the next 7 days. Okay, here's the ocean swell chart. We have 39-foot swells in the core of that system. And currently off San Diego in Southern California, we've got 17 and 12-foot swells right out here. All right. Here is the SSEC geostationary satellite. This is the water vapor loop. And we can see some of the moisture fields moving through, a moisture field moving through Southern California. This was all laced with chemtrails. We'll see this on the MODIS Today map. And we've got a lot more moisture moving in. Even though we've got high pressure installed into place, a lot of this will make its way in, and they will have to continue their spraying activities. And also notice this anomaly right up in here. That is not normal. That is where they are focusing heat. Actually see some disruptions right here. There's some shock waves right in the core of that system moving out. Okay, let's take a look at the this is the MODIS Today color satellite showing all the chemtrail activity, all the aerosols being sprayed. LA is right here, and we have Point Conception right here, and a huge area of chemtrails that were sprayed. This eventually blew on shore around 2 o'clock in the afternoon. All right, so that's the, let's take a look quickly at the 500 millibar. We can see that low pressure is centered right down here over New Mexico and Colorado. All right, and the 300 millibar. See the see that storm out on the Pacific up here, Hurricane 4 storm. There we have that low trough of all this low pressure down here. And we have no rain in the forecast despite this huge storm. All right, so that's pretty much the summary for today. The one last thing, we've got this, this is a cross section of a high bypass turbofan engine. Take a look at this. And the way these work, in the old days, the jet engine, get this zoomed in a little bit better. All right, so this is a modern high bypass turbofan engine cross section. We can see the multi-stage turbine compressor right here. And in the old days, all of the thrust was derived from the exhaust gases moving right out of this area right here. But with the modern high bypass design, most of the thrust is derived from the cold air being sucked in and compressed by this large fan here and just blown right out the back. So most of the air bypasses going through the engine entirely, and so the thrust is derived right from this fan, and it goes right out through the nacelle without ever moving through the turbine itself. And so the result of all that is that the exhaust gas temperature out here on the back side of this engine is much lower. You've got basically ice cold air when you're flying at altitude, very cold air at 15, 20, 30,000 feet, 40,000 feet. You're talking about minus 30 to minus 50 or 60 degree air moving in through the front of this engine and combining with the hot exhaust out the back. And so you have a net result of much lower exhaust gas temperatures, and that's going to, you're not going to have contrails on the modern bypass engine design. And that's basically all there is to it, is you have a much lower exhaust gas temperature combined out here out the backside. So that's basically it. We have a lot more air moving through the engine by this large fan than we do moving through the compressor, which is actually powering this fan. This is how a turboprop engine works essentially. On a turboprop plane, you have a propeller right here, minus the nacelle, and that's how you get the power. So these are high efficiency engines. They get a lot better fuel mileage, cents per seat mile, and they move a lot of air and they're much more efficient, and they don't generate contrails. So that information is easily found on the internet, and I suggest that if you don't understand how that works, just look it up on YouTube or look it up on the internet. There's plenty of articles about the money that was spent on this design and why it works and why it's better. Okay, so that's it. Let's take a look at the, we'll just end this on the, what we're watching here. That storm that went through California dumped 1 1/3 inches in the foothills, and it's moved out of California and it's developed into something a little bit larger, but it's still being hit by a transmitter. We can see all that violent activity right there, and of course the vertical velocity maps show a lot of descending air, and we can see the evidence of that by this clockwise rotation. The end result is that all that weakens the core, and so these very large storms are dumping a lot of rain back east, but not much over California. And that's curious. I wonder why that is. Okay, so that's it. We will do another update tomorrow.